A 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 concentration of calcium hydroxide. What was the concentration of HCl in the original solution? So we can start by writing a balanced equation. So we have HCl and calcium hydroxide are added together to yield water and calcium chloride. And we'll go ahead and balance that. So we put a 2 there and a 2 there. Okay, so the equivalence point is the point where just enough calcium hydroxide has been added to react with hydrochloric acid. So we'll go ahead and draw a picture to make it a little easier. So we know we have a 75 milliliter solution of HCl. So we'll go ahead and write those ions, and these are the ions that can be found in 1 mole of HCl. And we're adding calcium hydroxide. To the HCl to titrate it. Now the concentration of HCl is unknown, so we'll go ahead and write that. But we do know the concentration of calcium hydroxide, which is 0.157 molarity. And the calcium hydroxide is also in a 27.3 milliliter solution. Okay, so what I know that the we know the concentration and volume of calcium hydroxide, and we can use these values to find the moles of calcium hydroxide. And then once we find the moles of calcium hydroxide, we can use the chemical equation to convert the moles of calcium hydroxide to moles of HCl. And then since I have moles of HCl, once we have the moles of HCl, we can find the concentration of HCl by using the equation volume times concentration equals moles. So I'll go ahead and write this out real quick. So we can use volume times concentration to find moles of calcium hydroxide. That'll be our first step. Our second step will be to use the chemical equation to convert moles of calcium hydroxide to moles of hydrochloric acid, and then we'll use the formula volume times concentration equals moles to find the concentration of hydrochloric acid. So before we solve, the first thing we need to do is convert the milliliters into liters. So we'll just move the decimal point 3 places to the left. So we end up with 0.075 liters of hydrochloric acid solution and 0.0273 liters of calcium hydroxide solution. So we'll go ahead and solve. So we know we have 0.0273 liters of calcium hydroxide solution times the 0.157 concentration, which will give us 0.0042861 moles of calcium hydroxide. So now that we have the moles of calcium hydroxide, we can convert that to moles of hydrochloric acid by using the mole-to-mole ratio. So we'll take 0.0042861 moles of calcium hydroxide, and we'll look at the equation, the balanced equation, to find the ratio of moles. So we have 1 mole of calcium hydroxide, and then we'll multiply by 2 moles of hydrochloric acid, which gives us 0.0085722 moles of HCl. And now our third step will be to find the concentration of HCl by using the volume and the moles of HCl. So volume times concentration equals moles, and we know that we have the moles of HCl and the volume of HCl, but we need to find the concentration. So we'll go ahead and rearrange that equation, and so we'll get concentration equals moles over volume. So we have molarity equals 0.0085722 moles of HCl divided by, and we get our volume from here, 0.075 liters of HCl, and that comes out to be 0.114296 molarity for HCl, and that is our answer. So just common mistakes is first of all, forgetting to convert the milliliters to liters, because that will give you a completely wrong answer in the end. And also forgetting that the moles of HCl can be found from the moles of calcium hydroxide by using the stoichiometry of the balanced equation. And that's how you solve this problem.